Here we're going to look at the derivatives of two of our trig functions, and we're going to look at how we can find the derivative of our sine function and our cosine function. And basically these are two derivatives that you're just basically going to have to memorize. For example, if we want to find the derivative of sine of x, again with respect to x, the derivative of sine x is just simply your cosine function, the cosine of x. And then the derivative of your cosine function is negative sine of x. So really, these are just two that you're really going to have to simply memorize. So if we apply that to our first example, y equals 3 sine x, if we find the derivative y prime, the 3 is just a constant multiplier, so the 3 we're just going to bring down. And the derivative of sine x, based on the definition up here, is simply cosine x. So again, the 3, just in the previous video you probably watched, 3 is your constant multiple, so the derivative of sine is cosine, and then we simply multiply by the 3. Now the next example, we have y equals sine x divided by 5. And again, this is one of those problems that we probably want to rewrite so that you can visually see the problem a little bit better. And if we're dividing by 5, we could simply pull that out front as a 1/5 multiplied by the sine of x. And then if we take the derivative, we can clearly see the 1/5 once again is just a constant multiplier. So if we're trying to take the derivative then of the sine function, it's simply going to be again the cosine of x. So as you can see with these sine and cosine functions, you're basically just memorizing the derivative of sine is cosine and the derivative of your cosine is a negative sine. So if we look at the next example here, 8x plus cosine x, well, again, because these are added together, you can think of this as two separate functions, function 8x plus cosine x. And again, we don't have to write these down separately. We can just simply take the derivative of 8x. Well, that means you have an exponent of 1, so 1 times 8 is 8. And if you decrease the exponent by 1, you would get 8x to the 0. So the derivative of 8x is simply 8. And then if we take the derivative of cosine, now be careful, the derivative of cosine is a negative sine x. So therefore the derivative is 8 minus sine x. And the next example for finding y prime, we have negative 8 cosine x. So again, negative 8 is simply your constant multiplier. So we simply take the derivative of our cosine x. And again, the derivative of cosine is a negative sine. And then we could simplify this and we could write negative 8 times negative sine. The two negatives make it a positive. So we have 8 sine x. And this is where you have to really be careful. Again, the derivative of cosine is a negative, and the problem already has a negative, so the two negatives actually make it a positive. So that's one thing to really make note of here, and be careful. Sine, the derivative of sine is positive cosine. The derivative of cosine is a negative sine. All right, so that's basically it for finding the derivative of sine and cosine. You just simply have to memorize the two. I do want to go a little bit kind of in depth here with looking at the graph of our sine function and the derivative. We can see here in pink, or in the purple here, we have y equals sine x. This is the graph of your sine function. And we have the graph in green is the graph of our cosine function. And over here, if y equals sine x and we take the derivative, we get the derivative is cosine x. Well, remember, this derivative cosine x is representing the slope of our sine function. So what that means, for example, if I was to look at on our function sine x, if I was to pick the point here on our graph, we know at this position our x value is 0. And if we want to know, we can look at the graph here. What is the slope of our tangent line here? In other words, here would be our tangent line at x equals 0. What is the slope? Well, the slope is what we look at for the derivative. Well, our derivative is the cosine. So that means this point right here on the derivative graph, when x is 0, that tells us that our y value is 1. So that tells us the slope is 1. And if you look here at x equals 0, if we were to draw a tangent line in here, it looks like we would certainly have a slope of 1. And if we continue along the graph here of sine x, if we got here to the top of the graph, let's see, I'm sorry, let's stick with the same color here. If we pick this point here at where we have pi over 2, okay, so when x is equal to pi over 2, we want to find the slope of our tangent line. Well, the slope of this tangent line is going to be based on what we have on our derivative, which is the cosine. So at pi over 2, if we look at the cosine function, that point is here. And what is the value at pi over 2? Well, when x is pi over 2 here, we end up with 0. So that's telling us that we have a slope of 0. And again, we have a horizontal line, so the slope certainly is 0. And if we continue along the graph here, we can look at this point, and here we have a value where x equals pi, and we can look at the tangent line here. It's going to look something like this. So it looks like the slope there is going to be negative. Well, if we go to the derivative, which is our cosine, if we go to the point here at pi, what is the slope? Well, when x is equal to pi, our y value is a negative 1 over here. So therefore, the slope is a negative 1. So clearly, this tangent line here is going down, so it certainly would have a negative slope. If we continue along the graph here of the sine function, if we go down to this point, we're at the location of x is equal to 3 pi over 2. And once again, what's the tangent line? Our tangent line is horizontal. So what do you notice? That's where the graph here crosses the slope, the cosine function, which means we're going to have a slope of 0. Okay? And if we go to the very last point here, we could continue on, but this last one here, we have x is equal to 2 pi. And if we look at the tangent line, we know this graph continues up. Our tangent line is going to look something like this. So therefore, the slope, again, if we go to this point, we can tell that our slope is going to be positive 1. So I just want to kind of point out that here, when we have our sine function, we can see that here in the purple graph, and the derivative in green, the cosine, that is telling us the slope. So you can kind of compare when we have the blue dot, the slope at that point is the red dot above it here. So here we have the point at 0, this red dot at the top on the derivative graph. The graph of the derivative tells us the slope is 1. When we're at x equals pi over 2, we can see down here the slope is 0, and that continues on around. So that just kind of verifies up here, if you have sine of x and take the derivative, that's certainly going to be the cosine function. And very similar, if you looked at the graphs, the derivative of cosine is going to give you a negative sine x. So once again, these are two derivatives that you simply have to memorize.